Assalamu alaikum. Welcome back to this properties of circle part 3 should be. Yep. So here we are going to learn about the second property, equal chords. This is not really hard actually. We have to combine the first property and this one together to learn it better. So let's get started. First of all, you see from here, let me just make it a bigger way here. If you see two chords equal, this AB is a chord, this CD is a chord. We have two, remember S, it means two. So if they are equal, then it shows that the line from center to the chords is equal. Okay, so we write it equal chords. We have equal chords first, so that makes equidistant from center. So from center, it is equidistant. The other one is just the opposite of it. First of all, we have a 90 degree, and then we have a chords equidistant from center equal. So here they are same, right? This OM and ON, they are same. That will show that your chords are also the same. All right, and the reason is chords equidistant from center are equal. These are chords, they are equal because we have equidistant from center line to the chords. So if you get it until here, then let's do the questions. First one. We have a PQ chord and RS chord here. We already know that they both are 20 cm. They are both same, right? So it's given. If that is the case, both chords are same, then there is a equidistant from center, which makes OM equals to ON, and the reason is equal chords equidistant from center. Please write this reason over here. Yeah, equal chords. You have to remember the spellings. I am very bad at spelling, because when I did DSC, it was in whole Chinese. It was easier actually, but then this one is also not that hard. So we already know OM equals to ON, so they both are 6. We don't write CM here. That is because there's a CM next to A already. If you write another CM, then it will be ACM. That doesn't make sense, right? So let's continue. Next question. This is just the opposite of it. We already know that the line from center to the chords are equal. So ON and OM are equal. They are given. It can be seen from the figure, so we call it given. So that's why RS will be equals to PQ. These both chords will be equal then. Then both of them will be 8. No need to write CM again because we have a CM already here. And the reason here you have to write chords equidistant. I'm sorry for the pronunciation because my English is super bad. All I care is maths, so who cares about English anymore? Yeah, until here it's done. Let's continue then. Let's try with the examples. We'll give you example first and then you can continue the practice. You can pause the videos, try the questions, and then check it back by replaying. So we have a AM equals to 4. Okay, if that gives you information, that means we have to use that as well. Remember why I said that it's just the second part of the first property? We have to mix it together. That is because from center to the chord we have a 90 degree here, right? If that is the case, then the chords are bisected. This AM will equals to MB. Both are equals to 4, alright, 4 cm. That is the case, right? So that's why we know AB is 4 times 2, which is 8. The whole chord is 8. Next step, we know BC is 8. Oh, we already know BC, that is 8. These both chords are same. If the chords are same, what can we know? Yep, the line from the center to the chords is also the same. We will know that ON equals to OM. The reason is equal chords gives the equidistant from center. So both of them will be 6 because one of them is given here. So they both are 6 cm. We are writing CM here because next to ON we don't have the CM. Yeah, so it's needed. So you try the practice, you can pause it. Okay, then if you're back, let's write what we have. PM equals to 12. Oh, we have half of it, right? Can we know the other half? Yes, it's also 12 because it came from the center with the 90 degree. So the whole PQ is 24. That was given 90 degree. There's a 90 degree here. And then we also know that the RS is also 24. That means they both are same. RS and PQ, they both are same, 24 cm. So that gives that the chords are same, then the central lines for them will also be same. OM will equals to, yep, ON, they both will be equals to 5 cm. Alright, because ON did not have CM with it, so you write the CM. Easy peasy. Then let's get continued. Here, number 3. So we have a PQ here, and then we have RS here. We know that RT is 14 OM. Okay, this first line first. OM equals to ON. What does that give you? Yep, they are the center lines. It comes from center to the chords, right? And they are equal, so that shows that your chords are also equal. So if PQ is 16, then if PQ is 16, then RS is also 16. The whole thing is 16. Alright, we already find RS actually. And then we know that RT is 14. This half part is 14. The whole thing is 16. So what's left? ST will be 16 minus 14, 2. Yeah, if you see it clearly, the whole thing is 16. RT is 14. So what is left? Yep, 2. Continue then. This figure, I just make it bigger because I couldn't see such a small one. It's hard to write on it. So first thing, perpendicular bisector. Oops, we already know it. And then we have AB, the whole thing, as 10. And then we know CP, this small thing, is 2. And then we have this angle, same. So do you know in triangles, if two angles are same, what happens? Yep, if two angles are same, then the two lines are also same. We call them isosceles triangles. Okay, that's the opposite of isosceles triangle. If two lines are same, then the two angles are same. Alright, so that case, ON equals to OM. Oh, that gives you something important, right? If ON and OM are same, that shows their chords are also the same. Alright, that already shows CD equals to BA. And then because we know they are 10, it's written here. They both are 10. And do you still remember? Okay, we already find one of the thing. NP is here. Do you still remember the first line? So let me just erase it so that it's easier for you. The whole CD is 10 cm. And then that was a perpendicular bisector, so this is half. DN is 10 over 2, half, right? And then NC is also half. This whole NC is 5. We have a 2 here. What is left? So NP will be 5 minus 2, which is 3. Because this perpendicular bisector showed a lot of the information already. It's a perpendicular here, and then it's also bisects. Bisects means make it equal. Make CD as an equal from N. Alright, so that's for this one. And then the last question for this video. We have chords here, and then between the chords we have the central line to the chords here, OM and ON. Oh, it's already given they are same. If that's the case, then we already know that these are also the same. We will already know that because OM equals to ON, so CD equals to AB. We will have to use it in a while. What else do we know before these? We know that ON equals to 6. Hey, do you see anything special already? See this triangle. It's a Pythagoras. Pythagoras means there's a triangle with 90 degree. Then these two will be add up, square it. It will be called Pythagoras theorem. Same goes here. It was 10, 6, we don't know this, so cn square plus 6 square equals to 10 square, and then move this 10 square and 6 square together, it becomes this. We have 64 here and under rooted because we don't want the square, so you get the 8 here. Yeah, you already have 8 here. So what will be the other part? It's also 8 because there's a center and then there's a 90 degree, it goes from here, so it is a bisector as well. So if this is 8, this is also 8. So the whole CD is 8 plus 8, which is 16, and then we already know AD, CD and AB are same, so it is both 16 cm. So that's all for this style. If you have more question, you can feel free to ask on the IG, same page, DSC Maths Urdu, and or even you can ask in the comment section down below. Thank you.